So good evening, everyone. This is lecture number 6, JEE Advanced, and I think we were dealing with electric current, right? The last
Yes, sir.
class we saw some good problems on current in circuits, and now we'll try to wipe up the rest of the problems together with some problems on instruments. Okay. So I think the last class I gave you homework to do a problem. Yes or no? Do you remember this?
Yes, sir.
Did you try that problem? The problem was like this. This is example number 33. I think you have got your sheets, right?
Yes, sir.
Example number 33. What is the current in milliamperes in the wire between points A and B? All the resistances are given in kilo ohms, and the battery car voltage is given as 32 volts. You are supposed to find out the current in the wire AB. Did you do it? Get the answer?
Yeah. Got 16.
Got the
16.
answer?
We got 16, sir.
You got 16, sir. 16 in which branch? You got 16, but the answer I don't think is 16. The answer I think is 8. So it was an integer type question, right? The answer I think was 8. Would you want to try again or shall I do it?
So explain, sir.
Okay, so you want me to explain. So how do you do it? See, there are different ways in which you can do this. And I think the way which is given here, I think is quite good. Now, see, do you see a sort of symmetry in this circuit? Yes or no?
Yes, sir.
What sort of symmetry you see? We call it inverse symmetry. 1 kilo ohm is here. This is not 1 kilowatt. This is 1 kilo ohm. 1 kilo ohm is here. 2 kilo ohm is here, and 2 kilo ohm is here. So what is going to happen if I say that this current is I2 goes into this branch? The same current I2 will come out from this branch. Do you understand this?
Yes, sir.
Similarly, if I say the current in the 1 kilo ohm upar wala resistor, the resistor which is on the top is I1, then the current which flows through the lower resistor would be also I1. Now, if you get this, if you understand this, it's great because now you can straight away find the values. You can just apply this loop law in this way. You will get the value of I2 from here. Yes or no?
Yes, sir. Understood, sir.
If I just apply loop law in a different way, if I apply the loop law in this path, I will get the value of
We'll get
I1.
I2.
And then you can do I2 minus I1 or I1 minus I2 depending on which is greater. You will get the value of the current flowing in the arm which was connecting. This is one way of doing it. Else you could have done it in a different way. How you could have done it in a different way? Just take everything off. I could have done this in a different way, but again that method would be a bit longer. So what you want to do is these two resistors are in parallel. Yes or no?
Yes, sir.
These two are also in parallel.
Parallel.
When they are in series, you can find out the current from there. Then you can divide the current, and then from there also you will get your answers. Okay,
Yes, sir.
that is other way of doing it. Doesn't matter. Whatever way you do it, you should be able to get the answer. Now, let's move on to the next one. Okay,
Okay, sir.
this one again. These type of questions are going to trouble you sometimes, and they are pretty simple if you do it once. And this is a very good question. In the circuit shown below, all the voltmeters are identical and have very high resistance. But remember, this resistance is not infinite. So we cannot call them infinite resistances. Okay. So they are not ideal voltmeters. They're identical voltmeters having the same resistance, which is very high. Each resistor has some resistance. The resistance is not given. The voltage of the battery is 27 volt. What is the reading of the voltmeter V3? If you can find out all the voltmeters, it would be great. But the question only asks the voltmeter V3. I'll give you time, 2 minutes to solve this good question. Remember, we are not doing traditional questions where you simply have a circuit and you are supposed to find out current in that circuit, because those questions are pretty easy in that case. We are trying to do different questions. And as I said, this sheet is a good one. I'll give you 2 minutes to do it. V36, that is exactly correct. How did you do it? It was not an easy question. How did you do it?
So I took between V1, V2, I took a X, sir. potential difference.
Okay. Then you applied the nodal theorem. Yes or no?
Yes, sir. Nodal theorem.
Okay. Have you done? Had you done this question before, or you?
No, sir.
Did you
अभी किया.
okay.
Now.
You did not look at the solution.
No, sir.
Great.
Just I.
Great. But tell me, how did you get this as 9 and this as 18 and this as 27? Okay, you can understand this is 0 and this is 27. How this is 9, how this is 18, and how this is 27? That is the main point of this question.
From positive charge, sir, carries sir 27 up to Arna, sir.
This is also 0, yes. This is 27, yes. How did
0.
you get 9, 18? Remember, this voltmeter is having a very high resistance. That means literally no current flows through that voltmeter. Do we understand this?
Sir, what, sir?
It was given in the question. Remember, everything that is given in the question is like diamond. We should not miss anything that is given in the question. It was given in the question that what?
High resistance.
So that is the catch of this question, because they have very high resistance. Then what will happen, bacha, is literally no current will flow through them. Yes or no?
Yes, sir.
That's it. So no current flows through them. So current only flows in the upper branch through R1, R2, and R3 like this. Oops, I cannot do this because will not take this. So the current will only flow in the branch, in the upper branch like this, and in the lower branch like this. And all the resistances are same. Therefore, the voltage drop across each resistance would be same, and that would be equal to 9 volts. That was the catch of this question. Now you can call this as X.
X.
Then I1 plus I2 plus
X
I3 is equal to 0, and you will get this answer. Do we get this?
Yes, sir.
That was the catch of the question. If you could do it on your own, well done. You have done it correctly.
Okay.
Good. Then comes this one, another integer type. Remember, integer type are always easier compared to multiple choice. The most difficult question in a JEE are normally multiple choice. Remember that. Comes this one. Again, you're not doing conventional questions. A wire of length L and 3 identical cells of negligible internal resistance are connected in series. Due to the current, the temperature of the wire is raised by delta T or delta theta in time T. Example number 30. A number N of similar cells is now connected in series with a wire of the same material and same cross section but of length 12. The temperature of the wire is raised by the same amount delta T or delta theta in the same interval. What is the value of N? Good question. Okay, 2 minutes. Remember, questions are framed in such a way. Understand the framing language and what is asked. Remember, this question is mixed. It contains two topics mixed together. Do you understand this?
Yes, sir.
So it's a question that is partly belonging to electric current, but also partly belonging to something known as calorimetry, which we just did 2 classes before. Yes or no?
Yes, sir.
So that's your hint. Solve it. I'll wait. It's a pretty simple question, beta. In first case, we have 3 batteries connected to each other. In second case, we have n batteries connected to each other. What we have done with the wire is we have changed the length of the wire from L to 2L. Do we understand this? The wire is same, cross-sectional area is same, material is same, only the length has changed. That was the catch point of this question, and then the question is pretty damn simple. If the original resistance of the wire is R, then the resistance of new wire will be 2 times R, yes or no?
Sir.
Can easily find how much energy will be lost in the form of heat in the first wire. You can find out the current, then you can do it, or you can do it anyways. You will get this 3V square, 3V the whole square by R into T, yes or no?
Yes, sir.
Similarly, in the second case, the resistance has become 2 times R, and the
Yes,
number
sir.
of batteries has become NV.
I got it, sir.
Okay, but remember, in the first case, the heat is mc delta T. In second case, Q dash is M dash. The mass of the wire is also changed. If you forget this point, your answer will be not coming correct because the length has become twice, the mass also has become twice. Did you miss this point? Now
Just
both
this
the
point, sir.
you got this point, beta?
Yes, sir. Got it, sir.
So now you can divide number 1 by number 2. You will get the value of n as 6.
Yes, sir.
Where were you caught? In which part?
I didn't take a
Mass is twice.
Sir.
Okay. Remember this question?
Specific, yes, sir.
MC delta T specific heat, yes. Yeah, this is specific heat. This is not molar specific, this is specific heat.
Sir, specific.
Yes, beta?
Specific.
Cells? I'm not getting what are you saying, beta?
Battery low, sir.
Which battery? Okay, okay, microphone. Okay, don't worry. You can just signal if you can't talk, okay? I can see you, don't worry. You are on the screen, I can see you. You can just raise your thumbs and I'll ask you questions. If the answer is no, you can just say this. If the answer is yes, you can just say this. Don't worry. Okay, so we are done with this, bacha? Okay, don't worry, I can see you. My camera, that's why I log in by 2 devices, so that from one device I can see you, because from the laptop I can only do I can only write and I can see, and the thing also runs on this. The Zoom thing also runs on this. Now what we are going to do is do this very interesting question. And I'll have to probably reduce the size so that this question comes. And this is a very good one. And I don't know, any question of this type can actually come in your JEE. I hope you can see this. You can see a balanced Wheatstone bridge. I think they have marked it wrongly. This would be your A, this would be your C, probably, and they have marked it wrongly. BD. It's a conceptual question, multiple choice, correct? Show the balance Wheatstone bridge. If P, so this is P, this is Q, this is R, this is S. Remember that. If P is slightly increased, the current flows from C to A. If P is slightly increased, the current flows from A to C. If Q is slightly increased, current flows from C to A. The last option is A to C. 4 options. Remember, multiple choice questions are the more difficult ones. You have 2 minutes to do this. Once you are done, please just signal to me. If you get one part correct, the other all parts will come, right? So if you increase the value of P, what is going to happen is the potential of point C will decrease. Yes or no?
Yes, sir.
And hence current will flow from A to C. If Q is slightly increased, potential of point C will increase and current will flow from C to A. Do we get this?
Yes, sir.
Great, great, great. There are some really great questions coming up, interesting ones. And these are the type of question that you normally see in a JEE paper. So please be careful. Simple question, conceptual based. To understand them, they are simple cakewalk. A cell of internal resistance 1 ohm is connected across the resistor, as you can see. A voltmeter having variable resistance is used to measure the potential difference across the resistor. The plot of voltmeter reading V against G is shown. What is the external resistance R? G is the resistance of the galvanometer. Remember, it's a galvanometer that is converted into a voltmeter or an emitter. After this is done, we will jump onto those conversions and those devices and see how questions are framed in electrical instruments. So once we are done with this, 3 or 4 questions are left. We'll jump onto the devices, solve some question on devices. So I'll give you 2 minutes. The answer, I guess, is 5 ohms. And you missed the point. What happens when, when does this become 20 volt? When G tends towards infinity, yes or no? It's
Yes,
like
sir.
asymptote. It touches this at infinity. When this becomes infinite, this becomes ideal galvanometer. Yes or no?
Yes, sir.
When it is ideal galvanometer, it is reading 20 volts. That is the resistance across. That is the potential difference across the resistor R. What is the current? So I call the current as I. 24 minus I into 1 should be equal to 20. Yes or no? From there, you can find the value of I. Once you get the value of I, this 20 will be equal to I into R. From there, you will get R as 5 ohms. You got 4. Probably you got the value of the current, not the resistor.
Okay, sir.
Understood what you had done correct and what you had done wrong? What were you thinking? How were you trying? Understood, or shall I explain again?
Yes, sir.
Got
Got it, sir.
it?
Got it, sir.
Okay. This one, a very simple question. Just test whether you can do it fast or not. A time varying current is passed through a resistor R as shown in the figure. What is the total heat generated in the resistance? Obviously, we are talking about time starting from 0 to 3 T naught. What is the heat developed in the wire? Total heat produced in the wire. The time varying current.
We'll get, sir, integration of limit 0 to t, 3 I naught by t naught into t, then r dt. Area under the graph, sir. Area under the
I
graph.
square R dt beta. You should
I square,
do I
I
square
square
R
dt.
dt,
Yes, sir. Yes,
not
sir.
I R dt. Okay. So what you got to do is you got to find the equation of this line, which is I as a function of t. The equation of this line will be like this. You square it, multiply by R, multiply by dt and integrate it. This is very simple. It's a constant current. This is also very simple. It is constant
Yes, sir.
current.
Yes, sir.
Find out the current, square it,
Yes.
multiply by R, multiply it by dt, and you are done. Once you integrate it, you are done. Do we understand this?
Yes, sir. Got it, sir.
Okay. Remember, see, why are we doing all sorts of different questions? Because I don't want you guys to think about these questions, and I can assure you, one of these questions you will find similar question in the examination hall. Okay, we are trying to cover all types of questions that are possible. Trust me, I'll cover all of them. Okay, shall we
Yes, sir.
move on to the next one?
Yes, sir.
And this type of question has come many a times where they frame it in this way that um, a student is conducting an experiment on Ohm's law. He connects this thing to here and this thing to here. Similar sort of question is made. Here it is put in a different way. Okay, a candidate connects because it's an experimental thing. I've seen question of previous year JEE where they've asked which arrangement or which circuit is going to tell the Ohm's law correctly, what will be the error and all that. Similar question. A candidate connects a moving coil voltmeter, a moving coil emitter, and resistance R as shown in the figure. The voltmeter reads 20 volt and the emitter reads 4 amps. What is the value of R? Equal to 5 ohms, greater than 5 ohms, single option correct. Less than 5 ohms, greater or less, depending upon its material. I'll give you 2 minutes to think about it. So here is the next question. The candidate connects voltmeter V, emitter A, and resistance R as shown in the figure. The reading of the voltmeter is 20. The reading of the emitter is 4 amps. What is the value of resistance R? You have 2 minutes. Got the answer as greater than 5 ohms, and that is absolutely correct. See, it's a very simple thing. Whatever current passes through the voltmeter, the rest of the current out of
Yes,
4,
sir.
the total current is 4. So if X goes through the voltmeter, 4 minus X goes through the resistor. Yes or no?
Yes, sir.
And voltmeter is reading the voltage drop across the resistor. Yes or no?
Yes, sir.
So this 20 will be equal to 40 minus X. No, not 40. 4 minus X into R. So R will be 20 divided by 4 minus X. This cannot be equal to 5. It has to be greater than 5. Yes or no?
Yes,
That
sir.
is how this was done. Okay. This is again a pretty simple theoretical one. I hope you can do this quickly, fast. An electric current flows through an insulated strip PQ of metallic conductor. The current density in the strip varies. Okay, current density is varying. Which one of the following statement could explain the variation? Why this current density is varying? From point P to point Q, the current density is current per unit area is varying. Why is this varying? The strip is narrower at P than at Q. It's a single option, correct? The strip is narrower at Q than at P. The potential gradient along the strip is uniform. The resistance per unit length of the strip is constant. You have 2 minutes. Option A.
Strip is narrower.
The strip is narrower at P than at Q. That is exactly correct. Current flowing through the strip is same. Current density at point P is high. That means area has to be less. And if I talk about resistance per unit length of the wire, it is rho L. The resistance is rho L by A. So wherever you have more area, resistance would be less. Do you understand this?
Yes, sir.
That is how you get this answer. Well done if you could do this. What about this one? Next one. The circuit shows. Remember, these are the type of questions that are in fashion these days. The circuit shows a battery, rheostat, and two identical lamps, P and Q. What will happen to the brightness of the lamp if the resistance of the rheostat is increased? Lamp A, lamp P, lamp Q. These problems sometimes trouble you. They are just theoretical problems based on simple things. I'll give you 2 minutes to think about this. Remember, whenever you come across such a question where you have a variable resistor and they change the resistance of that resistor, think about the extreme cases. Extreme cases. What do you mean by extreme case? If this is a rheostat whose resistance can be changed, if I make the resistance of this wire as 0, no current will pass through this. Yes or no? So lamp P would be the brightest and Q will not glow at all. Yes or no? Yes
Sir,
or no?
I didn't get, sir.
Once you have the resistance of the rheostat as 0, the current will just flow like this. Yes or no, beta?
Yes, sir.
So Q will not glow at all. Only P will glow, and P will glow the brightest because the resistance, because there is only resistance of P, there is nothing else in the circuit. Yes or no?
Yes, sir.
If I make the resistance of this rheostat very high, no current will flow through this branch. And in that case, Q will be the brightest. Because if some current flows through this, less current flows through the other one, through Q. So that means from 0 to infinity, what is happening? P is getting dimmer and Q is getting brighter. Yes or no?
Yes, sir.
That's it. Simplest explanation, the Q-test answer. Do we get this?
Yes, sir.
This is how you must think.
Okay, sir.
Again, a question where you have to think. Single option. Here it comes. In which of the following arrangement of resistor does the emitter, which has a resistance of 2 ohms, give the largest reading? When the same potential difference is applied across point P and Q, M is the emitter. It also has its resistance. Potential difference is same. In which case does it read the maximum value? Again, a question of your understanding. This is how questions are framed in a JEE. 2 minutes. It is very simple, yeah. In the first case, 3 are in series. If I assume that the potential difference is E, in first case, current is E by 4. In the second case, 1 and 2 are in parallel, then it is in series. So the current is E by 2 by 3 plus 2. In third case, all are in parallel. Current is E by 2.
Sir, in second case, E by 2 by 3 plus 2, how it came, sir? Plus 2?
Arey, 1 and 2 are in parallel, na beta? 1 and 2 are in parallel, it is 2 by 3. 2 by 3 plus 2. Total resistance. Yes or no?
Okay, yes, sir.
You have the sheet, right? You can look at the question,
Okay, sir.
right?
Yes, sir.
So it is 3 8 by 3, 3 8 by 8, 3 E by 8. Third case E by 2. Fourth case all are in parallel, E by 3. Fourth case 1 and 2 are in series and the other 2 is in parallel. Same potential difference applied. E by 3. Which is more? E by 4, E by 2, E by 3 or E 3 E by 8?
E by
E by
2.
2. Simple question. Yes or no?
Yes, sir. I got confused in B, sir. I got all the 3, but
But you made a mistake with B, right?
yes,
Simple
sir.
mistake will cost you 4 marks. It will not cost you 4 marks. It will cost you 5 marks. 5 marks means you
Very
will
huge rank.
lose a lot of ranks. Maybe even 5,000 ranks you can lose on 5 marks. Okay, try harder. You're doing good, but you're doing silly mistakes. You should avoid those ones. Example number 4. How will the reading in ammeter of the figure be effective? Another ideal bulb is connected in parallel to P. P and Q are bulbs. With this question, we'll move on to electrical instruments and solve some questions on electrical instruments. So this is the last one on this category.
It will be get double, sir, on C.
It will be double because the distance is
Ah.
halved. It's as simple as that. Okay, you got this?
Yes, sir.
Okay, now let us move on fatafat to some electrical instruments. And I hope you know a bit about galvanometer. Yes or no?
Sir?
You know about galvanometer?
Yes, sir.
Okay, so I'll just show you this one. This sheet you don't have probably. Have to. I hope you can see this, right? It basically works on the principle that if you have a current carrying coil placed in a magnetic field, it will experience a torque. You remember this, yes or no? The torque on this coil is NIAB. Do you know this? A is the area, I the current in the coil, N is the number of turns, B
Number
is the
of
magnetic
turns.
field. That
Yes,
is
sir.
equal to C theta,
Yes,
where
sir.
C is known as the torsional constant of the spring, or sometimes it is known as restoring torque per unit area, per unit angle. So I is directly proportional to angle theta. So how much it has turned will give us how much is the current. This C divided by NAB, sometimes known as the galvanometer constant. Do you know this?
Yes, sir.
Okay. If you know this, then you must be also knowing what do you mean by sensitivity of the galvanometer. Yes or no? Just go through this. Sensitivity of the galvanometer is nothing but deflection per unit current. Do we understand this? How much it deflects for a unit current. If you don't know this, you can note this down, because if a question comes directly on this, if you don't know the definition, you will not be able to do anything about that. Okay?
Sir, I will not, sir. I don't know the topic.
Write it, write it. I know you might not know it. That is why you write it. If you have noted this, then you should also note voltage sensitivity. Current sensitivity was current per deflection per unit current. Voltage sensitivity is deflection per unit voltage. Theta divided by V is theta divided by I into Rg, where Rg is the resistance of the galvanometer coil. Theta by I is NAB divided by C. So it becomes NAB divided by N divided by C into Rg. Just note this formula. Okay, then you must be knowing how to convert a galvanometer into an emitter. Yes or no? You connect a small resistance into shunt. Do you know this?
Yes, sir.
Do you need to note this down?
I will not serve it, sir.
You don't know this?
No, but
Note it down. Note it down. Remember here, Ig is the galvanometer current. Sometimes you also call it full scale current of galvanometer, full scale deflection current of the galvanometer. Here, this galvanometer has a resistance which is known as Rg. This is known as S or R shunt. Total current which you have to measure is I. Whatever current goes in galvanometer is known as Ig. Whatever remains goes here. That will be I minus Ig. Please note it down. Conversion. Know the formula for the conversion?
don't know, sir.
Don't know this? Okay, then you can note down this. Ig into G, basically potential drop across the galvanometer, or the potential drop across the shunt would be same. So Ig into G will be equal to I minus G into shunt. From there you can find out the value of the shunt resistance. Okay. Note down this formula. Then the effective resistance of the emitter. Two resistors are connected in parallel. So it is G into S divided by G plus S. I hope you see this formula. For an ideal emitter, the resistance is 0. Then you can also note down the conversion of a galvanometer into a voltmeter. So what do you do to convert a galvanometer into a voltmeter? You connect it in series with a very high resistance. Do you see this? A very high resistance R is connected in series, and you have Rg which is the resistance of the galvanometer. Ig is the full scale current that multiplied by R plus G, because both are in series, will be equal to V. This V is the voltage that this voltmeter can safely read. So this is the range of the voltmeter. Do we understand this?
Yes,
So
sir.
V would be given, galvanometer resistance would be given, Ig would be given. To find out the value of this R, then the effective resistance of the galvanometer of the voltmeter becomes R plus G. For an ideal voltmeter, the resistance has to be infinity. You know this, right?
Yes, sir.
Note this down. I'll give you a question based on this. Then you can just solve this problem and see if you understand this. A galvanometer has a coil of resistance 60 ohms. That is the resistance of the galvanometer. Shows the full scale deflection. That is Ig. To convert this galvanometer into an emitter of range 10 milliamps, what is the shunt resistance required? So just have to put the formula, get the answer, and stay happy. You can do this.
Yes, sir. Always.
2 minutes. To solve this question, you just need to remember the diagram of galvanometer into an emitter, and you just remember that potential difference is same. So you basically need to remember that Ig, and remember this, Ig, galvanometer full scale deflection current, into G will be I minus Ig into shunt. Do you understand this, beta?
Yes, sir.
Everything here is given. Ig is given as 50. Coil resistance of the galvanometer is given as 60.
Yes, sir. Got it, sir.
This is given as 10. So everything is given and you should be able to deal with this. Yes or no? Got this?
Yes, sir.
Okay, then fatafat solve this one for me, so that I understand that this thing is locked and I can move ahead. So this one comes now. A galvanometer is a coil of resistance 100 ohms and shows a full scale deflection when 100 microamperes pass through it. Resistance required to use it as an emitter. No, as a voltmeter of 5 volts is how much? Well done, bacha. You just have to put the formula, get your answer, and stay happy. Okay? Do I need
Yes,
to
sir.
solve this, or you have understood this?
समझ गया सर.
हो गया ना? Okay. Now remember, the way a question may be framed may be a bit different. So look at this question, and probably the first thing you will notice is the exam in which this appeared. What does the exam say? Rootki 87.
Yes, sir.
So remember, there was a point in time during my time, 1997. Roorkee was just Roorkee. It was a regional. It was not even a regional engineering college. It used to have its own exam. It was known as CEE, Combined Entrance Examination. Roorkee 87. Here is the question from Roorkee 87. A galvanometer having 30 divisions and a current sensitivity of 20 microamps per division. It has a resistance of 25 ohm. To convert it into an emitter measuring up to 1 ampere and voltmeter up to 1 volt, what are the resistances required? Your time starts now.
No, sir.
The only thing that would have troubled you, or you should have guessed, is what is the full scale deflection current? If you know the value of Ig, everything is done because everything else is given. And it's very simple to understand what is the value of Ig here. It is given that it has a current sensitivity of 20 micro ampere per division. Yes or no?
Yes, sir.
And there are 30 divisions given. Yes or no?
Oh, yes, sir.
So from here, you just get the value of Ig. Once you get the value of Ig, you can
Yes, sir.
get
Got
the
it, sir.
value of shunt. Yes or no?
Yes, sir.
Then you can get the value of the series resistor as well. See, this
Yeah,
is how this question
simple.
was done. I had to show you this because the question that comes in the JEE may be like this, just to make it look tougher than it actually is. Then we come to your favorite topic. Potentiometer is what you wanted to discuss. Yes or no?
Yes, sir.
Okay, so this is simple thing about potentiometer. It does the same thing as a voltmeter does. It can measure voltages. Uh, it's a very sensitive device, and it can measure unknown resistances. Whatever you can imagine, the potentiometer can do. It does not draw any current from the main circuit, so we can use it for measuring potential difference. You might have read about its uses. Potentiometer is used to find out the value of internal resistance of a battery to compare the EMF of two batteries. Yes or no?
Yes, sir.
But but you can use it to measure voltages. At the same time, you can use it to measure unknown resistance as well. Meter bridge, it is also something like a meter bridge. The only thing is meter bridge has 1 meter long wire. Here the wire is very long and therefore it is more sensitive. Do we understand this?
Yes,
So
sir.
whatever a meter bridge does or whatever a voltmeter does, the potentiometer can do the same thing, and it can do the same thing more precisely. And that is why it is a very sensitive device. Do we understand this?
Yes, sir.
Okay, sir. So, what is the principle on which it is based on? Do you know the principle on which it is based on? The principle it is based on is pretty simple, that if you have what? A constant current is flowing through a wire of uniform cross sectional area, and here we are assuming that the resistance of the wire is going to remain constant. Heat developed is not going to change the resistance. What will happen is the potential drop across any portion of the wire is directly proportional to the length of that wire, because resistance of the wire is rho L by A. Do we understand this? Yes or no?
Yes, sir.
If rho and L remain constant, resistance of
With
the
R
wire
is
will be
also.
directly proportional to L. Yes or no?
Yes, sir.
And with the resistance is directly proportional to L, and the resistance does not change with temperature, the potential drop across any 2 points will be proportional to the length of that portion. Do we understand this?
Yes, sir.
Okay. Now, it basically consists of two circuits. Have you seen this diagram before?
Yes, sir.
Have you
Yeah.
seen this diagram before?
Yes,
If you
sir.
have not seen it, just remember, because whenever a question comes on potentiometer, bacha, JEE will not ask you straight away find the ratio of EMFs or just put the formula and get the value of R. They will not ask you this. What they will ask you will be a question based on the basic principle of potentiometer. So if you don't know this diagram, you have to draw it. It has a primary circuit. Do you see the primary circuit? This primary circuit has a battery and you have a wire. Now the length of this wire, if it is made very long, it becomes more sensitive and it can measure very, very small changes also. Then you have a secondary circuit. Do you see this secondary circuit? In the secondary circuit, if you connect two batteries or you connect a battery with an internal resistance, you can find out the internal resistance of the battery, as well as you can compare the EMF of two batteries. Do we understand this?
Yes, sir.
Primary circuit, secondary circuit, and then you have not talkie, but this is a jockey, and you have a galvanometer connected to a jockey, and by moving this galvanometer, you can do a lot of things. Do you know this? Yes or no?
Yes, sir.
Okay. So, what will happen when your jockey or your galvanometer does not show any deflection? What will happen in the secondary circuit? when your jockey or the galvanometer is put in a state where it does not show any current, it will not draw any current from the main circuit. Yes or no?
Yes.
That means the potential difference between point A and B will be same as potential difference between X and Y. A and B, I think, are points A and C. It should not be A and B, it should be A and C. A and C are the points on the wire, and X and Y are the 2 points of the secondary circuit where you have connected some unknown things. Yes or no?
Yes, sir.
So this is how it will work. So whatever happens in primary circuit will not affect the secondary circuit when it reaches balanced state, because there will be no current drawn from the battery, uh, because the potential difference between A and C and X and Y would be zero. Do we understand this?
Yes, sir.
So this is the basic functioning of potentiometer. Then you have something known as potential gradient. Potential gradient is the potential change in potential or drop in potential per unit length. Do you know this?
Yes, sir.
Okay.
Sir, I have one question doubt, sir.
Yes, say.
OPOIQ. वो एक सर्क्यूट है सर.
Yes.
It is a circuit, sir.
Yes.
I will draw circuit in and show on camera, sir.
Okay. Let us. It is related to potentiometer.
And no, sir. It is related to capacitors and resistance.
Yeah, there would be
Electricity.
capacitor and resistance, and something has to be found to
Yes,
find the
sir.
charge on the capacitor. We'll be doing that in the next class. Don't worry.
Okay,
We'll
sir.
be covering that resistor and capacitor RC circuit in the next class. Don't worry.
Yes, sir.
Okay. Don't worry. We'll cover it.
Okay, sir.
Okay. Chalo. So you know the basic theory behind this potentiometer.
Yes, sir.
So if I give you a question, you will be able to solve this, right?
Yes, sir.
Okay. You know how you compare the EMF of two batteries?
Sir?
And how do you find the resistance of the internal resistance of the battery? Yes or no?
Yes, sir.
Okay. That means I can straight away jump onto a question, and let us see if you can solve this one. This is again based on the concept of potentiometer. Remember, a potentiometer can do a lot of things, and I hope you can see this question completely. Yes or no? In the following circuit, a 10-meter long potentiometer wire with a resistance 1.2 ohm per meter, a resistance R1, and an accumulator of EMF 2 volts are connected in series. Then the EMF of the thermocouple is 2.4 millivolt. When the current in the galvanometer is zero, what is the current supplied by the accumulator? Oh. You understand the meaning of accumulator? Accumulator is nothing but the battery that is connected there. Any idea how this will be solved? Give you time to think about it. If you understand the concept, that then the question is pretty damn simple. The potential difference will be I multiplied by the resistance R of the wire. Yes or no?
Yes, sir.
Resistance per unit length of the wire is given. So you multiply this resistance per unit length is lambda by L into I, that will be equal to V. So you can find out the current I. I will be equal to lambda V divided by lambda L. Yes or no?
Yes, sir.
It is pretty simple. Did you get the concept?
सर अभी भी क्वेश्चन नहीं क्लियर हुआ सर मुझे.
Question नहीं clear हुआ. Question was pretty simple, beta. I'll show you a diagram probably. You can see the diagram. I hope you can see the
Sir.
diagram.
Sir, is there any changes when it is hot junction and cold junction? Is there any changes?
No, beta. This is just a thermocouple, right? Now, when the galvanometer reads 0, there is no current in this thermocouple. Do we understand this?
Okay, sir.
So the potential difference between these 2 points is given as 2.4 millivolt. Yes or no?
Yes, sir.
There is no current going in the lower branch, the secondary circuit. So if the current here is I, this 2.4 millivolt will be proportional to I multiplied by the resistance of this wire. Yes or no?
Yes, sir.
The length of this wire is 5 meter and the resistance per unit length is given as 1.2 ohm per meter. So you know the resistance of this wire, multiply it by I, you will get V. V is 2.4. So from there you get I. Do you understand this?
Yes, sir. Yes, sir. Clear,
That
sir.
is how this question is done. Remember, the question in JEE will not be straightforward. Getting my point? They will put it in this way that you get puzzled. If you don't understand the theory behind it, you would get caught. Got it?
Yes, sir.
Next one. In an experiment for calibration of voltmeter, you don't know what the calibration of voltmeter is. A standard cell of EMF is balanced across. So it's a voltmeter, it's a potentiometer question. Standard EMF, cell of EMF, 1.1 volt is balanced across 5.50 length of the potentiometer. If the current of 0.1 ampere passes through a 2.3 ohm resistance, then the balancing length for the potential difference across the resistance would be how much? The question clear?
No, sir.
Okay. Then you should be able to give me the answer. Remember, questions are simple.
Sir.
Remember, the entire concept of potentiometer is the potential gradient remains constant. Yes or no?
Yes, sir.
First data, you have 1.1 volt getting balanced by 5.5 meter. Yes or no?
Yes, sir.
From there, you can find out the potential gradient. 1 divided by 5. Yes or no?
Yes, sir. I got
Now you have to balance 0.23 meter, 0.23 volt. What will be the balancing length? And the answer is pretty simple. Yes or no?
Okay, sir. Yes, sir.
See? Simple, no?
Simple.
Potentiometer question are pretty simple if you understand the concept behind it. If you don't, when they will trouble you, and this is again a question based on potentiometer wire, but put in a different way probably. And the question reads like this. In the circuit shown in the figure, if the current distribution remain unchanged on connecting E, what is the value of E? Same. It's a question on potentiometer. Yes or no?
Yes, sir.
So can you tell me the answer? It's very simple. It is based on the potentiometer concept. This is how questions are framed in a JEE. So basically, instead of connecting the battery and a jockey and connecting the battery from one end of the wire, they've connected the battery in between the wire. You can assume that this entire wire is of some length, then it has some resistance per unit length. This is a question of potentiometer. Yes or no?
Yes, sir.
You get the answer, beta?
Wait 1 minute, sir.
So the answer is pretty simple, isn't it? You just find out the current in the entire circuit. Now we have done it for three resistors R1, R2, R3. It could be an entire wire. Similarly, the question has to be done. You get the value of I as 0.5 ohms. Yes or no? 5.5 amps. Yes or no?
Yes, sir.
Then you find the voltage drop across the 8 ohm resistor, which is 4 volt. The battery ka EMF must be 4 volt. Then only the galvanometer will show zero deflection. Yes or no?
Yes, sir. So, 1 minute.
The answer is 4 volt, and that is how questions are framed for potentiometer. Do you understand this?
Yes, sir. Yes, sir. Clear,
Are
sir.
you, are you now confident about potentiometer?
Yeah, yes, sir.
Well, then this finishes our today's class. In today's class, we have covered almost everything that was possible in current. I think we have not done any question on I think drift speed and all that. So probably tomorrow I'll see if I can get time. I'll do 2 or 3 questions on drift speed and all that, because it might come and people neglect it. And then we will try and do RC circuits which have resistance and capacitors, and how do you find out the voltage of the capacitor, charge of the capacitor, how do you find current and all that. So we'll deal with that thing in the next lecture. If you have any doubts, you can ask. Else, this is a wrap from my end. Wishing you all a good night,
Waves
beta.
complete करना sir. Waves start का waves.
So tomorrow we'll do that RC circuit and then we'll start with waves. Okay.
Yes, sir. पूरा starting से start करना sir. कुछ भी नहीं था.
Okay, वो पूरा starting start कर दूंगे. So I'll send you the sheet for RC circuit if I have. I'll see.
Yes.
Was for separate sheet on RC circuit I might not have. I'll check if I have. I'll send it to you. Okay.
Okay, sir.
Okay. Take care. Have a good night,
Bye.
beta.
Bye, sir.